These are the frequently asked questions for pre-calculus for the test of sections 1.1 to 1.3, and this is for day 1. And number 40 was the first problem anybody had asked about, and it says solve the equation graphically by converting it to an equivalent equation with 0 on the right-hand side, and then finding the x-intercepts. So what we would do is just subtract this 2 square roots of x plus 8 from both sides. And that would give us the absolute value of 3x minus 2 minus of x plus 8 equals 0. And then they just wanted us to use the graphing calculator to see what that comes out to be. So we go into y equals, and we have to get that absolute value piece, so that's math, arrow to the right, numbers, number 1, 3x minus 2, parentheses, and, oh, actually with this version, I don't need the parentheses, there we go. So there's the absolute value of 3x minus 2, and then subtract 2 second square root of x plus 8. All right, there we go. So I'm going to do zoom 6 and hope for the best. And I see very clearly that there are 2 x-intercepts. So it is second trace, number 2 the 0, and let's get Blinky into position above the x-axis and press enter. And then as it says right, we're going to hit the right arrow to get below. And the 0 is at negative 1.086265, which we will round to negative 1.086. And then we'll go back and get the other one. Second trace, number 2. And this time Blinky will need to be below the x-axis to be to the left of it. And then we will press enter. And because I have so many things going on right now, the calculator is being very, very slow. There we go. Arrow up to the right, which is really above the x-axis. Hit enter through guess. And 2.864, either a 0 or an 8. Hard to tell with this bugger, so we will go with an 8. 2.864 will become 2.865. You know what, I think that is a 0 because it has a line through it there. It's so hard to tell. I'm going to go ahead and round it up and hope for the best there. It's hard to tell on the screen what we really have. So that is the other x value that we get for number 75. All right, let me clear this out in the hopes that things might move a little bit faster here. As I go to the next page. The next one that had been asked about was from page 94. And on page 94, number 14 said find the domain of the function algebraically and support your answer graphically. I am probably not going to do the graphical part with you, but I'll show you the algebra. So number 14, the square root of 4 minus x squared over x minus 3. Now, domain is the x's, and here's what I know. To do the square root of 4 minus x squared and stay in the real number system, that actually will have to be greater than or equal to 0, because if we have anything that's negative, it's going to be imaginary. So we would square both sides and get 4 minus x squared is greater than or equal to 0. Then we would subtract 4 from both sides and divide by a -1. And when we divide by a -1, we have to flip the sign. And then we take the square root. So x will be less than or equal to positive and -2 because we had to take the square root up here. So what that means is, really this is an and statement. So using the old Algebra 2 way, we would write that we have to be between -2 and 2. Now, when you look at the denominator, you'd say, well, we can't use 3. Well, that's okay, because with this interval, you can't use 3. So what we're saying is you can use -2, you can use anything up to 2, and include the 2. So that would be number 14. Then number 16, we have the square root of x to the 4th minus 16x squared. And again, we need that to be greater than or equal to 0, so we'll know how to restrict the domain. So we would square both sides, and that would give us x to the 4th minus 16x squared is greater than or equal to 0. And then we can see that we can do some factoring. We have a common monomial factor here of x squared, and then we would go ahead and find the other factors for the difference of two squares pattern that we see right here. So I notice that my zeros are going to come from 0, -4, and +4. So now I start thinking about the fact that this said greater than or equal to. At this point, we know where our zeros are, and what we're trying to do is figure out where this graph will exist. And just thinking here that this is probably as far as we have gone with anything. So what you would want to do at this point is you would want to graph it. Put it in the graphing calculator and see, okay, where does the square root of x to the 4th minus 16x squared exist? So we y equals, and we need the square root of x to the 4th minus 16x squared. So just using a tool that we know we can use. We know some cutoffs here of 0, -4, and 4. All right, we graph that. And there was our -4 cutoff and our +4 cutoff. And the one thing we do know that didn't show up here is that 0 is a part of this graph. If we put a 0 into that function, we will get 0, 0. So we have a little bit of a grapher error here in that it can't give us that point that we need. So now we can see that we need to go from -infinity, because that's going to be going to the left forever, up to our -4, and then we need to graph 0, 0, and then we need to go from 4 above. And so we'll go back and use interval notation to show that. So we'll have -infinity to -4, union with, we want to include 0, but we really need to use set notation for that. A point is not an interval. So we're going to accept if you also use that square bracket system here, but we really should be using set notation for that piece. And then 4 to infinity. So a combination here of algebra and using the graph to figure out what's going on with number 16. Then you had asked about 49 and 50. And the directions here state whether the function is odd, even, or neither, support graphically, and confirm algebraically. I think I'm just going to show you the algebra part of this. We have f of x equals the square root of x squared plus 2. And what we are supposed to investigate is what's going to happen if we put a negative x into this function. And notice that if we have a negative x and we square it, we're just right back to x squared. And because the original and f of negative x are exactly the same thing, that means that this is an even function. So if we graph it, we will see it is symmetric with the y-axis. Number 50, same situation. We have g of x, which is 3 over 1 plus x squared. And we want to investigate g of negative x. So that would be 3 over 1 plus negative x, the quantity squared, which of course, because it's negative, when it's squared, is just going to come right back to a positive x squared. And for the same reasons 49 is even, number 50 is even, because if we put a negative x into the function, we will get a positive x back out of it. We get the original function that we started with. So again, graphically, you could just plot these into the calculator. You're going to see that they are symmetric to the y-axis. Next up, in 13 through 18, identify which of exercises 1 through 12 display functions that fit the description given. So I'll grab that graphic and then be right back. For 18, it says the 4 functions that are bounded above. So basically we're saying the 4 functions that won't continue going up forever. Well, this is definitely going up forever, and so is this. Now, 3, that's actually, the graph is starting at 0, 0, and it's going down forever. So example 3 is bounded above. Then for number 4, anytime we have that cosine or sine wave, so we've got 2 of those, we know that's going to work. So example 4 and example 12. And we're looking for one more, and I see that I have that logistical function in number 11, and that one is definitely, remember, it has an asymptote above it. So that would be the 4th one. So 3, 4, 11, and 12. Now, get this closed up so it's not quite as slow. And in exercises 19 through 28, identify which of the 12 basic functions fit the description given. This one has the 6 functions that are increasing on their entire domain. So remember what that means is we are always going upward with these functions. All right, so what we could see is with the natural logarithm function, getting really hard to get the smartboard to behave itself with all of these graphics going at one time here. With the natural log function, we definitely are increasing. So we'll go back and write that down in a little bit. Sine function, no. Down, then up, down, then up. Cosine function, for the same reason, will be a no. Up and down. Absolute value, down, then up. So that is a no. Greatest integer function, well, it has this strange little jump that goes through it. And again, that's not going to be increasing over the interval. But logistic, yes. So far, we found 2. We have natural log and we have logistical. The identity, absolutely increasing the whole time. F of x equals x squared, no. We could see that we were going downward for a little bit with that one. Cubing function, absolutely. You start down here and you go up, and that is going up forever. Reciprocal, nope, just drew downward, not happening. Square root, absolutely. It is going up. It's not going up a lot anymore, but it's going up steadily. E to the x, yes. So we found them. Now we just need to go back and get them written down. So natural log, y equals x, cubic function, square root function, y equals e to the x, and then the logistical function. y equals 1 over 1. And the smartboard won't write it. So there's some kind of stall here. But again, the logistical function would be the last one. Oh, it's coming. It's going to print it out eventually. That's what happens when there's so many windows open. All right, so that would be the 6. Number 23 says find all the vertical asymptotes and horizontal asymptotes of the graph of the function. And we can see as we look at this one that there aren't going to be any of those vertical asymptotes because x squared plus 10, that's going to give us imaginary asymptotes as we look at the square root down there. So then the problem is, well, what about the horizontal asymptotes? Because that's the part where we talk about what's going to happen here if this is just 7 times infinity over infinity squared plus 10, the square root of that. And really, again, this plus 10 is spitting in the ocean. You know, it's just not going to add anything at all. So we have 7 infinity over, but now because this is a square root, we're going to get a positive and a negative infinity on the bottom when we take the square root of infinity squared. So that means it could be 7 over 1, which is just 7, or 7 over negative 1, which would give us a negative 7. So we don't get any vertical asymptotes, but we get 2 horizontal asymptotes of this function. Tad earns 25% more than his wife Felicia. Together they make $87,750 per year. What is Tad's salary and what is Felicia's salary? Tad, who we know makes 25% more than his wife Felicia. So he's going to earn what Felicia's earning plus 25% of what she's earning. And that tells us that Tad is going to be 1x plus 0.25x, which will be 1.25x. We also know that together they equal $87,750. So 1x plus 1.25x will be 2.25x. And then we can do a little division and we will have Felicia's earnings. And from that, we will be able to figure out what Tad makes. So 87,750 divided by 2.25 is $39,000. That is Felicia's earnings. And Tad makes 125% of that, so if we take that times 1.25, he will have $48,750. The next problem deals with a rate. We're talking about Jack and Jill, their next door neighbors in Wonka Land, the wonderful world of chocolate. Jack and Jill just happen to have the same size of chocolate pool in their backyard. It takes Jack 6 hours to fill his chocolate pool. It takes Jill 8 hours to fill her chocolate pool. If they worked together to fill just one pool, how long would it take them? So the rate is one pool is being filled, and it's the same every time. It doesn't matter who's doing it, it's one pool. Now Jack takes 6 hours, so one pool in 6 hours. Jill takes 8 hours, so one
Tiffany
pool.
Brown, please report to the guidance office. Tiffany Brown to the guidance office.
One
Thank
pool in 8 hours, and they're going to add that together, and we want to know how long would it take both of them working together. So now what we want to do is come up with that least common denominator for 6, 8, and x, and that's going to be 24x. We're going to multiply every one of these fractions by 24x. Here, 6 will go into 24 4 times, and we'll get 4x. Here, 8 will go into 24 3 times, and we will get 3x. And over here, the x's will cancel out, and we'll get 24. So 7x equals 24, and we'll just divide that out, and we'll see what we get. So x is 3.43, well, let's go 3 decimal places, 3.429. and that was in hours. Now, we might not wanna leave that 0.429, so we'll take that times 60, and that will give us approximately 26 minutes. So approximately 3 hours and 26 minutes.